what we did. So there's going to be a couple special cases that are really nothing different than what we've done, but they look a little bit different. All right, so we're going to kind of still solve by factoring. And then I'm going to show you a couple cases where it's a little bit different, but we're still doing the same thing in order to get our answers. All right, you'll see what I'm talking about once we get there. All right, so what happens when we kind of had a problem similar to this yesterday? Like if I have x squared equals 9x minus 20. So if I say solve, and this is the equation, what do we need to do first? Or what do we need to do in general? Okay, we're going to eventually have parentheses for it, so before we do that, in order to solve, what do we need to do to this equation before we can even start to make our parentheses? Nina? Yeah, you want to make it equal to 0. Okay, once we have it set equal to 0, now we can factor it. We can set our factors equal to 0 and solve those little equations. So what are we going to do to make this equal to 0? Subtract what? What? Add what? Okay, and now, okay, we're going to take the 9x and the 20 and move it to that side. Why don't we just take the x squared and move it over there? What? That would make it equal to 0, right? But then what else would happen if I move the x squared over there? You'd have a negative x squared. Have you ever factored anything that has a negative x squared? Well, you don't want to try either. You're scared, right? So let's leave it positive. You don't have to. You could actually factor out a -1 if you wanted to. But let's just move these things over here. How do you move things from one side of the equation to the other? You said it already. Add or subtract. So we've got a positive 9x, subtract 9x. Do it on one side, do it on the other side. We're subtracting 20, so add 20. Do it on one side, do it on the other side of the equal sign. Janelle, very good. You see him? He saw me look at him. Then he saw me look at him again. And then he was like, I should probably be taking out a notebook. Let's see if it works with other students. Oh, you do have a notebook out. All right, I didn't see it. I thought you were hiding it. Okay, good. All right, here we go. Boom. What do we got? Where am I? I don't even know. How do I combine all that? How do I combine all that? Why y'all looking at me like I'm weird?
I already read it. Just put the x squared to the front.
Yeah, you can't combine all that. They're not like terms. Good, Armand. Write x squared. Then write minus 9x. Then write plus 20 and set it equal to 0. Okay? Now, the next step is to factor this. We can maybe take out a GCF. Is there a GCF? Sebastian? GCF? No. Okay, if there's no GCF, then what? How do we factor it if there's no GCF? You do the thing.
Yeah. I don't know what it's called.
What's the thing?
Yeah, you find multiples of 20.
Factor by making. Thank you. Parentheses. 2 sets of parentheses. What goes here and here? X and X. What goes here and here? Yeah, numbers that multiply to be what? 20. So give me a guess, Dario, what multiplies to be 20? 5 and 4. All right, you want to do a 5 and a 4? What do you want your signs to be? Negative? Let's check. So a -5 and a -4. Now we check. Here and here need to give us this. So the reds multiply to be the red. The blues multiply to be the blue. Now we're going to check. We get a negative 5x and a negative 4x. Is that a negative 9x? No? Yeah. Negative 5? Okay, yeah. Okay, I thought I heard it no. Whew. Yeah, good. Done. Well, we're not done. If the direction said factor, if it just said factor, we'd be done right here. If it just said factor this expression, that's your answer. But it says solve, so we need to know what x is equal to. So what you do is you take the factors, x minus 5, set it equal to 0. You take the x other factor, x minus 4, and set it equal to 0. And now you just have two linear equations that you solve. Add 5 to both sides, x equals 5. Add 4 to both sides, x equals 4. Okay, so it's nothing different. It's just we need to set it equal to 0 first, then factor. All right, how is this one different than what we've seen, kind of? Or how is it even different than number 1? Go ahead, Haley. Okay, it's already everything's on one side. Eileen, what else? What? It's a binomial. Very good math word. Binomial means there's what? 2 terms. Yeah, this one had 3. Look, 1, 2, 3. This one only has 2. Normally, when there's only 2 terms, we were able to pull out a GCF. Is there a GCF? No. This is actually still the same thing as this. What's missing here? What's missing in this one that we had in this one? A number with an x, right? We're missing an x term. There's still an x term. What? Yeah, there's a coefficient of 0. That's why you don't see it. Basically, what this is x squared plus 0x minus 25. So that's 0. There's that x term's there. It's just not there because it's multiplied by 0. So we can still do the same thing. Make your 2 parentheses. This times this gives you this, which is what? X and x. And then the same thing, those 2 give you this. This times this gives you this. Blue to the blue, red to the red. What multiplies to be negative 25? Let's give a guess. Positive 5 and negative 5. And then when we combine and check, what do we get? 5x and negative 5x. 5x and negative 5x give you what? 0x. That's what we wanted. Those are the factors of this. Now, this happens because there's no middle term, and also because this is a perfect square and this is a perfect square. It's called a difference of 2 squares. What's a perfect square? 16 is a perfect square. 25 is a perfect square. 36 is a perfect square. 100 is a perfect square.
Is it anything that you can divide by itself?
Multiply by itself, you get that number. That number is the perfect square, yeah. So 5 times 5 is 25. 25 is the perfect square. 8 times 8 is 64. 64 is a perfect square. So here, another quick example. Number 3. If we have to solve 9x squared minus 100. Yep. You would make your two parentheses. What times what is 9x squared? 3 and 3. Good. 3x and 3x. And then we go, what times what is 100? 10. 10 and 10. We do a negative 10 and a positive 10 to give us the negative 100. Look what happens when you check. Negative 30x, positive 30x. The x's cancel out. They're gone. Those are the two factors. Once you have the factors, what do you do with them? Boris, this was your question from the other day. What do we do once we have the factors? X plus 5 equals 0. X minus 5 equals 0. Then what do we do with those? Yeah, you get x equals negative 5 and x equals 5 as your two answers. Okay? Same thing down here. You would set those equal to 0, solve. You would get 10/3 and negative 10/3. Yep.
Don't you do like this at the same time for number 2?
You took out a GCF of 1. You took out a GCF of 1.
Yeah, like.
And then you're still left with what you started with.
Yeah, but
You still have to factor that. So there's no point in taking out the 1. Okay? All right, now, if the directions just said factor and not solve, again, you would be done here. You would be done here. You don't have to go any further. Okay? All right, another problem that was similar to one that we looked at yesterday, a couple people had problems with. If it said solve like x squared equals 9x, something like that. So how would we solve that? Now, what's the first thing we need to do in these problems?
Make it equal to 0.
Nice. Make it equal to 0. So how are we going to make this equal to 0? Yeah, Brandon.
X cubed plus 0 plus 9x.
X cubed.
I mean,
X squared. Yeah, I want this to be a 0.
That's not x squared plus 0 plus 9x.
Why? Okay, so what you're trying to do is change it into this again, right?
Yeah.
Okay, I just want the whole thing. See how it's equal to 0? I just want a 0 over here.
Oh.
So how do I get rid of that?
Yeah. Subtract.
Yeah. Okay. Just move it to the other side by subtracting it. Minus 9x, minus 9x. So sometimes it's already equal to 0, right? Other times we got to set it equal to 0 before we factor. So if you subtract 9x from both sides, you get x squared minus 9x, and now on this side we have 0. Now what's different about this one?
2x.
There's two, what?
2x's.
There's 2 x's. There's only 2 terms, and they both have an x. So what do we call that? It is a binomial, but if they both have the same factor, that's a common factor. So how can we factor it? Greatest common factor, right? They both have an x term. Pull an x out in front and do the reverse of the distributive property. X times what is x squared? X times what is negative 9x? Once you factor it, Boris, then we set them equal to 0. This is one of the factors. X equals 0. Here's another factor. X minus 9 equals 0. There's one answer. Solve this one. X equals 9. There's your 2 answers. Following? All right. All right, how's the last one different? How's number 5 different? How's number 5 different? What's up, Ace? There's a 5? Yeah. What do we call that? You remember? First term? Coefficient? Yeah, the leading coefficient here was a 5. A lot of times when we do it, it's a 1. It's a 1, right? So what we did before is these are when we have to make the parentheses and guess and check. So you could start to do that on this one. Or do you notice anything about the numbers in number 5? Let's get a simultaneous answer by the two people I call each other the name. Ready? Go.
They're both multiples of 5. Yeah, that's what I was going to say.
Yeah, he was faster. Yeah. So what does that mean if there's a 5 in each one? What does that mean we can do? What does that mean we can do? Yeah, you could factor that out. That's a GCF. There's a 5, there's a 5, and 5 also goes into this. So we can factor it just like we did this one right here. Take out the GCF, pull out a 5, and then we're left with 5 times x squared gives us 5x squared. 5 times x gives us 5x, and 5 times -6 gives us -30. Now, isn't this a lot easier to factor than this? This in the green right here is just like this one. Make your 2 parentheses. Let's bring that 5 down and factor here. What goes here? I heard somebody say it. And then what's going here? 5 times 6 isn't 6. Now we're multiplying to be here. Okay? This times this gives you this. This times this gives you this. And then we're going to check to get this. Page, you're on fire. What is it? -3 and what? +2. You get a -3x plus 2x. Shoot, change your sign. Because that gave us a -1x. Yeah, +3 and -2 multiply to be this, combine to be the middle. Boris? Come on. Yeah, you get to answer that question for the rest of the year. Yeah. Was that yesterday?
Yeah.
That was yesterday when I quit?
Yeah.
Yeah. Then you guys let me back in. Thank you.
What's the point of the top?
The point of the top, this part, to make it easier. This is hard to factor. I mean, for that to factor, look, we got to do like 5x and x, right? And then we got to multiply to be 30. You can do 10 and 3. We can do 15 and 2. We can do 6 and 5. We can do 5 and 6. We can do 3 and 10. I mean, there's too many. It's harder because we have to do all this guessing and checking to try to get the factors. If it's possible, take out a GCF, and now you're left with this, and that's a lot easier to factor. This is easier to factor because the leading coefficient is 1. That's why we did that. Now, you can't always do that. Sometimes you can take out a GCF and make the leading coefficient 1. Okay? All right. I put 2 assignments in Canvas. They're both review assignments for the test. All right? One of them covers everything we've done in the unit. If you remember the first part of the unit, when we talked about monomial, binomial, trinomial, we talked about the distributive property, we talked about combining like terms. That stuff's on one of them. That one's called review by target. Okay, that one I would like you to complete the whole thing. The other one is called day 6.5. So it's like a review day after day 6 is kind of what I put in there. And that's just on factoring. So on that one, my suggestion is to do the odds. Okay, so on the one that says day 6.5, try to do the odds. And on the other one, it says review by target. I want you to do all those. We're not, but this is for today and tomorrow. We're reviewing today and tomorrow. Test is on Friday. So pick one. I don't care which one you want to work on today. You're going to work on one today. You're going to work on the other one tomorrow. Okay? So if you want to practice factoring, you do this one. If you want to practice everything today, you do this one. All right? I'm not collecting either one. You're not submitting either one. This is just review. It's practice. Some of you, I'll give you a little bit extra practice. I might have you do some of the evens just for a little extra practice with factor. All right? But these are the two in the canvas that I want us to be working on today. I'm going to review a little bit at the beginning of the period tomorrow, and then we'll finish up the rest of the practice. You know what's up? No, you don't have to turn these in.